And our study of dimensional analysis would not be complete without talking about atoms and moles and grams and doing a little bit of a chemistry application here. Okay, so first thing, I'm only going to overview it. I'll let the chemists talk more about all this. But the idea here is that for right now, we want to think about a dozen, and so we use the term dozen to talk about 12 entities. For example, we say a dozen is 12 eggs, and then so we can talk about, 2 dozen being 24 eggs, and 50 eggs would be how many dozen? Well, that would be like 4 and a little bit more. So it's a way of grouping things, right? It's another unit of measurement in a way. And so now in carbon 12, for instance, carbon 12 so if we look at 12 grams of carbon 12, there are 6 times 10 to the 20, or 6.022 times 10 to the 23rd atoms in that, and so this is the idea of the dozen in the atomic world, and it's called a mole. So we would say 12 grams of carbon is 1 mole, and that 1 mole has 6 times 10 to the 23rd atoms. Now, this idea of a dozen is going to vary from element to element. So the idea here is that when we look at 1 mole of something, that's the same as 6.022 times 10 to the 23rd atoms of that something. And so then and equivalently, if we look at a mole, we need to look at the atomic mass of that something in grams. Okay, and so here we have, using carbon as an example, you can see the numbers posted there, and then Avogadro's number is this magic 6 times 10 to the 23rd-ish number. All right, and so this is, again, not a unit of mass, so don't put a label of grams or kilograms after it. It's just a number of things, number of atoms, or in the event that we're studying compounds, molecules. Okay. All right, so we're going to look at this, and we may need this little slide this little excerpt of the periodic table as a guide here. But we're going to look at nitrogen gas, typically called N2, meaning you have 2 atoms of nitrogen in a molecule. And so we want to know, if we have 10 grams of nitrogen gas, how many atoms are present in that? Well, in these types of problems, I always like to think of, well, we want to begin with what we know. So we know we have 10 grams of nitrogen gas, and then now I want grams, but if we look at the previous slide, we know we go from grams to moles and then to atoms. Okay, so we have to figure out we have to convert between grams and moles first, and then once we're in moles, then we can go to atoms, and vice versa through all this. Okay, so if we look at 1 mole of nitrogen gas, and then we can look at the mass of that, we said it was the atomic mass, right? So the atomic mass of nitrogen would be 28, and here's how I got that. There's this 2 subscript of 2 means we have 2 atoms of nitrogen gas, so this is 14 plus 14. Okay, that's how I got the 28. Okay, and then so now I would have the units here after I did the math would be moles of nitrogen, but now I can convert this into atoms by saying, okay, I have in 1 mole of nitrogen gas, I have 6.022 times 10 to the 23rd, oops, let's try that again, erasing, 10 to the 23rd molecules of N2, and I'm using molecules because they're bonded together. Okay, and so if I do this all, do the mathematics out, okay, so now the moles would be gone, and I can multiply all this stuff straight across, and what I end up with is, and I'm going to use an approximation symbol here, approximately 2.15 times 10 to the 23rd atoms. And if I really wanted to, I should probably actually only use 2 sig figs, really only 1, but we can say this is that molecules of N2. Okay, Next, so just a recap, if you want to go from grams to atoms, you have to go grams to moles first via the atomic mass, and then from moles to atoms via Avogadro's number. Okay, and then so conversely, if we now are working backwards a little bit, where we have a half of a mole of oxygen gas, so 0.5 moles of O2, and we want to know how many grams. Well, that's just going to be, let's see, so I want moles of O2 to cancel, and I need moles of O2, and I need grams of O2, right? Okay, and so this is going to be converting using the atomic mass, and so you can see the atomic mass of oxygen is 15.99. We call that 16-ish, so we'll be off by a little bit, but close enough. Okay, but oh wait, it's not 16, right? That would just be if I had one atom of oxygen gas, but I have two, so this is 32, which is 2 times 16. Okay, so then at the end of all this, I get 16 grams of O2. Alright, and so next we have one final example. I want you to pause the video and try this on your own. Okay, well, and the quiz is going to give you the answer and check if you're right or if you're not yet correct. The solution here is going to be posted here in a moment. And here's the solution. Notice that there was a little bit more work just because he had to convert kilograms to grams, and that 8 ounces, it was really actually completely irrelevant. We didn't use it in the problem at all, so beware of that. So convert kilograms to grams, and then grams to moles via the atomic mass. And again, this 18 I got by using hydrogen, which is 1 plus 1. So there's 2 atoms of hydrogen, and then the one atom of oxygen in each molecule. Okay, so 1 plus 1 plus 16. And then per mole, and then convert moles to molecules via Avogadro's number, and boom, there it is. Okay. And that's going to be kind of our system that we're going to use in this course, converting between grams and atoms and moles. And then you'll see the same thing in chemistry. So have fun in both classes with dimensional analysis.